So, class 11th kinematics. In previous video, we derived equation of motion by three different methods, and we have seen a different condition in which these equation of motion can be represented. Uh, so, one major topic which is often used and in many of the numerical problems, that is displacement of a body in nth second uh, in uniformly accelerated motion. So it is not just the displacement. I mean, it is not just this s equal to ut plus half at square. It is more than that. It is the distance traveled in nth second. Uh, let me explain this nth second concept once again. Let us suppose there is an object, and after each second it is moving in such a way that after each second it is covering equal distance. So we can, after each second, we can plot its graph like this, its photograph like this. Okay, so after each second it is actually there is human error. It is almost at the same separation each time. Now let us suppose the same object moves some accelerated with some acceleration actually. Then in next instant it would not be here. It would be somewhere here, or in fact in next instant it would be somewhere there, and after that maybe outside of the scope, outside of the frame. So in first second it has traveled this distance. In second it has traveled this distance. In third second it has traveled this distance, and so on and so forth. So we can say in nth second it has traveled whatever be the distance. So that we are going to discuss here. For this we are going to derive a formula, and then we will not just derive it, we will do some special kind of numericals, or we can say special kind of theoretical problems on the basis of that formula. So let us suppose in okay, let us suppose displacement of an object. I am just showing some carelessness and writing lesser. Displacement in nth second, n seconds, that is s t equal to n equal to ut plus half at square. In the place of t we will put n. See, this is not the nth second displacement. This is the displacement in all n seconds. un plus half a n square. Now if we want to find displacement in 10th second, The easiest way, find displacement in 10 seconds, then find displacement in 9 seconds and subtract them. So also we are doing here. Displacement in n minus 1 second, that is s t equal to n minus 1, and that is equal to u n minus 1 plus half a n minus 1 squared, and then we can subtract them. So displacement in nth second, in most of the books I've seen they write it like this, Sn. Well, I also want to write it like this, but as it is a difference of two displacements, so I'm putting this delta sign as well for my understanding, so that I would not be confused. I'll subtract both of them, s t to the power n minus s t to the power n minus 1. So it is ut plus half at square minus, oh sorry, I've already put the value, that is equal to n, so we'll direct use that, un plus half a n square minus u n minus 1 plus half a n minus 1 squared. Alright, so next simply algebra is there, un plus half a n square minus un, I'm opening the brackets and adjusting the sign, you can do yourself and check final answer. So here it will be minus half a n square minus half a and then plus a n. You can do it yourself. First multiply it inside, expand its square, then open this bracket, then take negative sign inside. Later on when uh, you will be the expert of this, all this, then you will be able to solve it very easily. Okay, now there is an square will get cancelled, and un also get cancelled. Only the thing is left here is this u and rest of it. So we have now u plus a will be taken as common, and there will be n minus half. U plus a 2n minus 1 by 2. U plus half a 2n minus 1. Here it is. That's all. So on the basis of this, we are going to solve two problems of freely falling body. So free fall, we are going to discuss it in many cases, but free fall means where there is only acceleration due to gravity acting on the body. There is no other acceleration, no other force, no other effect, just the pure gravitation. So no matter which way body is going, we call it free fall. So generally it is literally it means body going downward under gravity, but it can be any kind of motion. It has been thrown in any manner, but if it is performing motion under gravity, then it will be ultimately it will be, because it ultimately will follow uh, a downward path, so it is called free fall. So first thing is, find the ratio between displacements in each second of a freely falling object. So let us suppose a body is freely falling, then what will happen? Okay, if it is uh, freely falling object uh, released from rest. So if a body is dropped from somewhere here, then initially its velocity will be 0, in 1 second, next second, maybe next second, and after which, see, you can do this experiment but safely from a tall building of 2 or 3 stories. More than that is also good, in fact superb, but there should be some safety. Then you can drop a ball, you can take its, you can record its motion, and then you can, if you will slow down it, you will come to know that initially ball travels lesser distance, than in very next instant it is traveling more distance, then next it is covering more distance. So we have to find the ratio between this to this to this and so on. So first of all, we will say that displacement in first second, so delta S1, as I have designed this, that will be u is 0, half g, acceleration due to gravity, that is g, 2 multiplied by 1 minus 1, that is 1. So that will be g by 2. Displacement in second, delta S2 is half g 2 into 2 minus 1, that is 3g by 2. Displacement in second, delta S3 is half g and 2 into 3 minus 1, that is 5g by 2 and so on. So delta S1 is to delta S2 is to delta S3 and so on is equal to, if we take ratio of all of these, it will be 1 is to 3 is to 5 and so on. That will be an odd number multiple. So odd number multiple of g by 2, and this ratio is called Galileo odd number ratios. So Galileo actually observed this, so remember it. Okay, other than that, there can be another question in which the same situation has been given, and they can ask you to find, I mean, entire scenario is same. Let me write it in a different form. If body is dropped and it moves freely under gravity, then find the ratios of difference between time taken by body to cover each meter of distance of displacement, in fact. So now we will shift our focus from displacement to time, and again body is freely falling, and see what we want here. If a body, let us suppose this multi-story building has been divided into 1 meter. That's silly to hear, but let us suppose it is something like that, or any other case there is a demarcation of 1 meter in a building. Then if a body is dropped at 0 time, then here maybe it will take t1 time, here it will take t2 time, here it will take t3 time. So what we have to do, we have to find the ratio of t1 minus 0 is to t2 minus t1 is to t3 minus t2. Well, this question has no direct relation with this formula, but still, because both problems look same, that is why I am considering it here. Okay, so uh, when t equal to t1, then s equal to 1 meter, and acceleration as we know it is g. So s equal to ut plus half a t square. So it will be 1 equal to, u is 0, so half g t1 square. That is t1 is equal to root 2 by G. Then T2, for T2 the body will travel 2-meter distance. So for T equal to T2, S equal to 2 meter, A equal to G. So 2 meter is equal to half G T2 square. From here T2 is equal to root 4 by G, or should I write it? Yeah, why not? And I can write it like root 2 multiply by root 2 by G. One more, T equal to T3, so S equal to 3 meter and A equal to G. We know that 3 equal to 1 by 2 G T3 square. So T3 is equal to 6 by G, which is root 3 root 2 by G, and so on. Job is not done yet. Now I'm crossing the border. I'm doing rest part here because I want to see all these results. So for first meter the time taken is T1 minus 0, that is root 2 minus by G. For second case, second 1 meter, T2 minus T1, that is root 2 by G minus simply root 2 by G, is root 3 root 2 by G minus 2 root oh god, G. So we can write it like this. So root 2 by G 1 minus 0. Here root 2 is minus 1. Here root 2 by is root 3 minus root 2, and so on. So the required ratio will be this root 2G root 2 by G will get cancelled. The required ratio will be 1 minus 0 is to root 2 minus 1 is to root 3 minus root 2, and this pattern will go on. So that was a very clever type of question, and its solution you can see, and you can just keep these results in your mind also. That, first, this relation for nth second, just keep this thing in your mind. And for free fall, distance traveled in each second, in odd multiple ratio is in odd, and third one each meter displays interval between difference over 1 meter is this complicated series. That's all in this video.